Hello friends, my name is Vasudev and I'm going to try to answer why coil guns are so inefficient by doing this experiment. We are going to shoot these different sizes of projectile. Of course they are all of same size. So let us start with this smaller one and shoot. So the capacitor bank is charging. That is the catching box right there. That's the catching box. It catches the projectiles. Oh, it is fully charged. And let us say the timing here. .6 milliseconds for the first projectile. We will note it down and calculate the velocity. I am shooting this one now. This projectile. Placed it. Capacitor bank fully charged. Fire. And let's take a look at this thing. The timing. It is 1.4 milliseconds. Now I am shooting this projectile. It is 25 millimeter long projectile, mild steel slug. Capacitor bank is fully charging now. So let us shoot. And here we got some readings. That is 410 milliseconds, or wait a minute. Yeah, we are getting the same reading, that is 1.4 milliseconds for this projectile also, because the previous projectile was almost of same size, same length. So now I have this projectile which is weighing 16 grams, 16.6 grams at 27 millimeters long. And this is the last projectile which I will be shooting. Let's charge the capacitor bank. Let us fire. Obviously the timing will be very less, because I'll tell you why the timing is very less. As you can see, it is 1.250 milliseconds. We are calculating the velocity now. Okay guys, after taking multiple shots, multiple trial shots, I took the average of all the value and I got these values. For the biggest shot which I fired, I got 4.7% efficient, and for the smallest projectile I got this much efficiency, that is 1.64 efficiency, and the maximum speed I reached is 65 meter per second. And these are all the velocities for the first, second and third, fourth projectile. So what this data says is, bigger the projectile, larger the magnetic saturation, so larger the magnetic attraction force. Attractive force will be greater if the projectile is bigger, or if its saturation limit is is it is at higher, in this graph, BH graph. So if I have a bigger projectile, the magnetic saturation increases, so my magnetic force, the resulting magnetic force in Tesla will also increase. So for me there is no problem in producing this field, that is H. So my coils can produce lot of magnetic field. I can pump in lot of current through my coil and bring a lot of magnetic field. But if I am producing so much magnetic field, my projectile should be in a position my projectile should be in a position to use all those magnetic field. It should be in a position to use all those magnetic field and get attracted with larger attractive force. So, like, because of this thing, that is because of the saturation limit, the limit to this saturation, because of that, we are facing the uh, lack of efficiency issue in the coil gun. Whereas in the case of rail guns, that's not the case. There is no magnetic saturation. Larger the current you pass through your projectile between those two rails, more are the accelerating force or the velocity at the output. So US Navy chose railgun instead of coil gun, according to my opinion. And this is my opinion on why coil guns are so inefficient. What we need to do is we need to find a projectile or a material, actually a material or an alloy, elemental material or an alloy which can saturate at high saturation limit. So if it has high saturation limit, we can get lot of efficiency at the output. This experiment proves this point. So you can tell your uh, opinion on this issue. So thank you for watching.